Ethernet refers to the family of LAN products covered by the IEEE 802.3 standard that defines the Carrier Sense Multiple Access Collision Detection Protocol, or CCNA-CD. 4 data rates are currently defined for operation over optical fiber and twisted pair cables. 10 base T Ethernet that supports 10 megabits per second, Fast Ethernet that supports 100 megabits per second, Gigabit Ethernet that supports 1000 megabits per second, and 10 gigabit Ethernet that supports 10 gigabits per second. The IEEE 802.3 standard provides MAC Layer 2 addressing, duplexing, differential services, and flow control attributes in various physical Layer 1 definitions, with media, clocking, and speed attributes. It also provides a lag definition similar to Ether channel for providing both higher link capacity and availability. Ethernet belongs to both the physical layer, Layer 1, and the data link layer, Layer 2, in the OSI architecture. 802.2 Logical Link Control Specification specifies the general interface between the network layer, such as IP, and the data link layer, in this case Ethernet. 802.3 specifies CSMA/CD network Ethernet specification. It specifies the frame format, cabling, and signaling standards. There are 4 available Ethernet frames. Today's network typically only uses the Ethernet 2 frame, although the current wireless specifications do use the snap frame. It is important to know that frame types are an exam objective. There are some very important fields used in an Ethernet frame. The first 2 I'd like to draw attention to are the destination address and the source address. The SA field indicates the source MAC address of the sending party, and the DA field signifies the destination, whether it's broadcast, multicast, or being sent to a unicast MAC address. Another very important field is the length or type field, depending upon which type of frame we're talking about. 802.3 uses a length field, but the Ethernet 2 frame uses a type field to identify the network layer protocol that it will be handing off the information to. 802.3 cannot identify the upper layer protocol and must be used with a proprietary LAN such as IPX or Novell. Since 802.3 cannot identify the network layer protocol by itself, it needs help. The IEEE defined the 802.2 LLC specification to provide this. An 802.2 frame is an 802.3 frame with the LLC information in the data field of the header, so we know what upper layer protocol to use. A snap frame is an 802.2 frame with a type field to identify the upper layer protocol. The DSAP and SSAP fields in a snap frame are always set to AA. These frames were created to work with more protocols than the 802.3 frame, and it uses the same code as an Ethernet 2 frame in the type field. Common uses of the snap frame are wireless and Cisco CDP. Please join me for the next lesson, Understanding IEEE 802 Protocols.